So let me just briefly say a few words about Dev. So Dev's a leading web operations consultant and is an author and a speaker and a principal at a consulting firm. So Dev has led transformations at many companies, including Salesforce, SolarWinds, and Cable and Wireless. And he's going to talk about, his talk is slightly different in nature than the earlier talks, which focused on digital transformation from a business or care delivery perspective or financial interaction with the customer. This is more about the plumbing of what makes any digital application work and how to make it work better. This is really focused on the operations of developing, supporting applications and infrastructure in an agile manner to enable digital transformation.
I mean, I really like Chloe's presentation because, you know, one of the things that we're going to talk about is that, you know, aside from the people who don't have internet access, which makes a digital transformation almost not really important, because if you can't get to the digital stuff, then what's the difference? But like even the companies that are taking their stuff into telemedicine and stuff like that, my argument is you need to be good at delivering software if you want to succeed at this. And if you're not good at delivering software, digital transformation is you're going to fail basically. And so I think it's applicable to sort of all of these different presentations. Is like how important it is when we're doing our transformations to become good at what we're doing, because if not, you know, we'll give some examples about it, but like, you know, that's not going to work out too well for your business.
I agree. So take it from here, Dave. Thank you.
Right on. So like you said, my name is Dave Mango. Today we're going to talk about DevOps for digital transformation. I have my own consulting company, Mango Tech. I work specifically on digital transformations, DevOps transformations, operational transformations. I've been doing this at different companies over the years, and you know, recently in the past few years, sort of made this my own company. And so, you know, to what Tula and I were just talking about, like my belief is that you know, DevOps is something we'll get into, but it's fundamentally about being good at delivering software. And so we won't get into what DevOps is right now, because I'm sure there's a lot of people who are like, what even is that thing? But, you know, there was a report that came out last year. It's called the Accelerate State of DevOps report. And one of the conclusions that they came to in this report was that the highest performers in these DevOps principles are twice as likely to meet or exceed their organizational performance goals. And I think that's really important, right? If we're talking about the importance of digital transformation, right? When we come out on the other side of our digital transformation, I think all of us would like to be in a situation where we're twice as likely to meet or exceed organizational performance goals, right? And these performance goals are going to be things like market share, revenue, customer satisfaction, all kinds of different organizational performance goals. But, you know, it's probably easy to agree we would all like that, right? And so, you know, I'm talking about delivering software. So how does that, you know, how does that apply to my company, right? I'm attending this conference. You know, we do telemedicine. What does that mean for me? Well, you know, Satya Nadella said, you know, for people who know him from Microsoft, every company is now a software company. Well, if every company is now a software company, then these ideas, this idea of being successful in our digital transformations, these ideas of being good at delivering software are going to apply to every company, right? No matter whether we're like a Facebook or whether we're a telemedicine company or, you know, any other kind of business out there. You know, you can go look at the job listings for, you know, engineers, and John Deere is hiring software engineers. Like they make tractors. Like how are they a software company? But it turns out they are a software company, and all these companies are software companies. And so, you know, this idea of digital transformation, we talk about a lot. We talk about, you know, success or failure. And so, Edward Demings had this great quote, survival is optional. No one has to change. So we don't have to go through digital transformations. It's not required. Nobody's forcing us to go through digital transformations. But I think what we'll discover, over the course of this talk is if we're not good at this, if we don't put the effort into this, then, that's going to cause a lot of problems for our company. So if everyone is a software company, obviously we have to do this. There was a great book that came out probably 2 years ago called Project to Product. I have it, pictured up here. It's by Dr. Mick Kirsten. And one of the things he talks about in this book is this economist, Carlota Perez. And Carlota talks about, or Dr. Perez, because I don't know her on a first name basis, talks about the different stages of evolution that we've had, mostly related to technology. So like, let's say in the 1800s, there was like the age of like the factory and automation, and then like, in the early part of the century, we had like assembly lines and for manufacturing and like the Model T and stuff like that. And what she asserts is that right now we're in the age of software. And this is a pretty significant change. And her thesis is that if we don't adapt to the age that we're in, we're going to get left behind, and that the companies who are best at the things that they do, that as they relate to this age that we happen to be in, are going to be the ones that win, and everybody else is going to, basically disappear. Like there's no like kind and nice way of saying that. And so if every company is a software company, and that means we have to be good at, delivering software, well, what happens if we're not? Right. And so, this is sort of everybody's favorite whipping post or whatever. But like a lot of times when we talk about digital transformation and people who were successful making these transformations, right? People talk about the killer bees, which was like Blockbuster, Barnes and Noble, and Borders, right? All the bees that, kind of don't really exist in any meaningful way anymore. I think I saw an article that said there's one Blockbuster video store left in the entire United States, which, for people like me who grew up, not in the past, few years, Blockbuster used to be everywhere. They were huge. They were like the 800-pound gorilla. Like if you wanted to rent a movie, like you went to Blockbuster. That's where you went to rent a movie. And so, Blockbuster is sort of famous for not making this transition, this digital transformation. Well, you can say like, hey, Blockbuster, they had this competition from Netflix, and really like, Netflix wound up just beating them because, we all know Netflix started, just very much like Blockbuster dealing with physical media. But ultimately, what did Netflix do well? They made this transition to streaming, right? Streaming movies. And so if only Blockbuster had this idea of streaming movies, then maybe they would have been successful. But unfortunately, Netflix came up with this idea. Turns out, totally wrong. Blockbuster, I mean, look at the date on this article. Blockbuster to stream Atom Films movies in 2002. It's not that Blockbuster didn't have the idea to stream movies. Like that was definitely part of their investment thesis for how they were going to grow their company and stuff like that. And, don't forget, they were the 800-pound gorilla in the room. So in 2002, they were already working on streaming movies. And I ran a content delivery network, a CDN, from 2001 to 2003. And I can't say which movie studio it was, but one of the major movie studios came to our CDN and they said, hey, we want to put our movies online and we want to stream them and we want to host the movies on your CDN. And, you can pretty much guess that never went anywhere, right? But like in 2002, people were talking about streaming movies. And so it wasn't about having the idea. So what year did Netflix finally release streaming movies? Well, it wasn't 2002. It was 2007. So Blockbuster had a 5-year head start on Netflix for doing streaming media. But now, you know, Netflix and chill, right? Nobody talks about Blockbuster and chill. That's not a thing. So why does Netflix have the ability to dominate in the streaming media space when the 800-pound gorilla in the room, Blockbuster, had a 5-year head start? It's because Netflix is good at delivering software. And so for people who have read, you know, The Lean Startup by Eric Ries, another great book, he talks about the thing that you want to do in the lean startup is you want to do experiments. You want to run as many experiments as possible. The more experiments that you can run, the faster you can find product market fit. The faster you find product market fit, the faster you can give your customers the things that they want. And so, you know, the title of this talk, right, is about agility, right? Being able to run experiments quickly and effectively is agility, right? If I want to know, you know, I'm some company and maybe I'm a Netflix or whatever, and I want to know how to get the best engagement out of our customers, like maybe I'm going to show, you know, surfing movies, and maybe I'm going to recommendations, and I'm going to show, you know, skiing recommendations to people who live in California. And I want to know which is going to get more engagement from people in California. Yeah, maybe it's seasonal, maybe it's not, who knows, whatever. But the ability to run those experiments is really important. And so being able to deliver software quickly and effectively is this agility. And that's going to give my company a leg up on my competition, because if I can run, you know, let's say I'm a company that, you know, let's go back to the Blockbuster days, 2000, 2001, you know, there were companies that were releasing software like 3 or 4 times a year. Well, you know, famously, like Netflix, Amazon, Google, everybody knows about these companies, right? They're releasing software thousands of times a day. Thousands of times a day. Now, I'm not saying that your company should be able to release thousands of times a day, like whatever, but let's say your company can release software 3 or 4 times a day. That means I can run 3 or 4 different experiments every day to find out what my customers want, what's most effective for them. If I'm a telemedicine company, what are the workflows that I can build into my telemedicine company so that the customer has the best experience, so they want to come back and use my telemedicine, you know, stuff all over again, right? So if I can release 3 or 4 times a day as a telemedicine company, and it can be simple things. It can be changing a button from blue to orange. It could be moving a button from here to there on the screen. Like, there's all kinds of experiments that we can run. And my competition is only releasing software twice a year. They can run 2 experiments a year. I can run 4 experiments a day. Who do you think is going to win in that market? Right? And so, you know, this is also the reason that these companies like Amazon and Google and all this other stuff, they can walk into spaces where they never existed before, where they're dominant, you know, the dominant players in those spaces, you know, get killed, right? Amazon they were selling books. And now there's Amazon Prime Video and Amazon Prime Music, and Google was a search engine. And, you know, that was great for ads, but now they have Gmail and they have, you know, Google's probably more famous for the number of products that they've killed than the number of products that they've, you know, that they've kept. But because Amazon, Google, because they are good at delivering software, they can walk into spaces with established players and take over those spaces, because they can run those experiments and find out what are the things that those people really want. And so, you know, if you go back to like Carlota Perez and things like that, look at the Fortune 50, right? You look at the companies that used to be on the Fortune 50, like in the 70s and the 80s, right? And the average lifetime for those companies was probably measured in decades. Well, look at who's on the top of the Fortune 50 right now. Is it ExxonMobil and all these other gas and whatever companies that used to be up there, IBM? No, it's like your Amazons, your Googles, your Facebooks, your Apples, like all these companies that are good at delivering software, because they have the ability to go into markets and take them over, because they have this ability, this agility, right? And think back to this first slide that we talked about. It said companies that are the highest performers at delivering software, because I'll assert that's what DevOps is all about, we're twice as likely to meet or exceed their company's performance goals. That's how Amazon and Google are doing this, because they can meet or exceed their company's performance goals. They're not bogged down in all these like crazy, well, we can only deliver software twice a year, we can't run experiments, we can't do any of that stuff. So, we're not going to get too caught up on like what the meaning of DevOps is in the terms of, digital transformation. But what we're going to say is being good at delivering software is the desired outcome for our digital transformations. And we're going to call that DevOps. And so for this next part of the talk, we're going to talk about different things that we have to be good at, which make us good at delivering software. And we're going to give some examples of the things that you can do in your company, things that you can focus on. This is the same advice I give to my clients when I'm doing consulting engagements. Like, you got to work on this, we got to work on that. Certainly with my clients, I help them with these things, but these are the things that you should be keeping in mind. And so there's 4 key areas that we're going to focus on, 4 key ideas. And these 4 key ideas are taken directly from that 2019 Accelerate State of DevOps report. And so the first one is deployment frequency, right? And we've been talking about this a lot, right? How can we run experiments? And in order to run these experiments, we have to be able to deploy frequently. We can't be deploying like every 6 months, because our competition is going to destroy us if they're deploying, 2 times a day instead of 2 times a year. And what if we have problems with our deployment frequency? What if we can only deploy at night, right? This is something I remember from, back in the Blockbuster days when I used to work at, software companies and stuff like that, working in operations. I used to be the guy who was up at 2 o'clock in the morning with the QA guys so we could release stuff in the middle of the night, because somehow we thought that was safer. It turns out totally wrong, oh well, we live and we learn, whatever. But, do you think that Amazon and Google only release software at night? What does that even mean? What would at night mean for Google? When do Google's customers go to sleep? When is nighttime for them? Google's a global company. They serve traffic all day long, every day, 365 days a year. There's no such thing as nighttime or whatever. So having this ability to deploy frequently, having this ability to deploy safely at all times gives us a leg up on our competition, and is one of the things that's going to make us successful in our digital transformation. So, I always, when I give my talks, I like to give people things that they can hold on to, not just, these lofty ideas or whatever. And so for deployment frequency, like, there's lots of different things that we can do to be good at frequently deploying. But so, some advice is like, work on trunk-based development. And so I know there's not, probably not most people in the audience are software engineers, so that's fine. Trunk-based development basically means that when I write software, it doesn't sit around for a long time before I get it in the hands of my customers. They call it short-lived branches, but like, it's basically like, if I'm going to release something, I want to get feedback from my customers on how good that thing was as quickly as possible. I don't want to wait for 3 months or 4 months to find out if my customers appreciate that. I want to know right away so I can keep on making my product better for my customers all the time, so that they're happier, so they're going to keep coming back, whether that's an online bookseller or whether that's a telemedicine company, right? I want my customers to be happy, because that's how I'm going to make the most amount of money as a corporation, right? Another thing you can do is revision control. And so revision control just basically means that when somebody checks in some code, it's tracked. I know who checked it in. I know what they checked in. I know, what happened to that software after they checked it in. So I can always go back and be like, hey, you know what? We released something, 2 weeks ago, and we've had really low engagement in our products for the last 2 weeks. What did we release 2 weeks ago? what is it that's causing problems for our, for our customers so that they're not as happy as they were, right? Because that should be a goal of our digital transformation, is happy customers. And so revision control allows us to do that, allows us to go back in time and track all the different changes that have happened so that we can make really informed and educated decisions about what we've learned. So the next metric we're going to talk about, or the next concept we're going to talk about, is lead time for changes. And this ties very well into our idea of deployment frequency, right? So deployment frequency is, how often are we deploying? But lead time for changes is, how long does it take from when I have an idea to when I can test that idea, right? How long does it take from when I have an idea for an experiment until I can test that experiment, right? And so the companies that are able to rapidly, experiment, this is all straight out of the lean startup, are going to be better at understanding what their customers want. So what we want to do is we want to lower our lead time for changes, right? We don't, if we have an idea, let's say product comes up with some great idea and they want to find out like when this is going to, what the effect of this idea is, the software has to get written, the software has to get pushed out to our customers, like all this other stuff has to happen. That's all measured in our lead time for changes. And we want to shrink that as much as possible. So what are the things that I can do in my company if I want to shorten my lead time for changes? And so one of them is automated builds. So we just talked about revision control, right? If I check some software into revision control, it's going to build something. It's going to build we call it in software, we call it an artifact that's going to get pushed out, that's going to run on our production servers, right? It gets pushed out to the web servers or the app servers, whatever servers it happens to need to go to. But like we're going to have our automated builds so that I don't have to run around and ask 10 different people for a favor to be able to get this software, ready for my customers to check it out, right? I check it in, there's an automated process that builds it, and then it's ready to go. And, we can do testing on this for quality. We can do all kinds of great stuff, but like that stuff has to be automated. And then when it's finally time to deploy it, we want single button deploys as much as possible, which means like I press a button and that software goes into the hands of my customers. I don't have to go around and ask people for favors. I don't have to have the database administrators prep a whole bunch of stuff for 2 weeks. And then like I go to the network folks and then they get their part ready. And then I go to these other folks and they get their part. I don't want to do all that because that's going to really affect my lead time for changes. That's going to affect the amount of time from when I have an idea to when I can actually run that experiment. And so I want single button deploys. I want to press a button and have that software out in the hands of my customers so my customers can be happy. And so that my customers can, either spend more money on my site or tell all their friends. This is a really great telemedicine product. Like you should definitely go check it out. All right, so the third out of the four is change failure rate. And, you can probably guess what this means, but, how often when we deploy software do we have problems? And like, I can tell you as a 20-something year veteran of the software industry, nobody ships perfect code every time. Doesn't happen. It doesn't happen in real life. It doesn't happen in the software industry either, right? You can expect that nobody's perfect. So what happens when we roll out software? How often do we have problems, right? Because if we're going to optimize our lead time for changes, we're going to optimize our deployment frequency. A bad deploy is a bad deploy, no matter how fast you do it. If you push garbage out to your customers 5 times a day, they're not going to be happy about that. It doesn't matter that you did it 5 times a day. They would rather you push out one really good thing once a day than 5 bad things. Like that's not good for them when they can't use your site. When they get on your site and they want to talk to a doctor and the software says, I'm sorry, there's no doctors available. And you're like, what are you talking about? 5 minutes ago, there was 100 doctors available. Now there's no doctors available. Like what happened? That doesn't make sense, right? So we want to be able to have a low change failure rate. And so some of the things that we can do in order to have a low change failure rate. The first one is code review. And this may sound really, really simple, but you would be amazed how many companies do not have code review. So if I'm going to check in my code and I need to have somebody else look at it. I need someone else to look at that and be like, hey, you said that you were going to be serving surfing videos to people in California, but right here in the code, it says that you're going to serve it to people in Minnesota. Is that really what you meant to do? How much surfing do people in Minnesota do? I mean, I've been to Minnesota. I know they have lakes, but like I would argue that there's probably not a lot of surfing unless, I guess you're being towed by a boat or something like that. So like you want someone to look at that code and be like, hey, you probably didn't mean to put Minnesota here. You probably meant to put California. And, that's important, right? The faster that first of all, we're going to lower our change failure rate because that thing's not going to get out to production and be a failure. And then we have to fix it. But also one of the things that we've learned in the DevOps movement is the earlier that we can catch these things, the cheaper it is to fix. If I ship something out to production and then I find out there's a problem, now I'm in a crisis. I need to fix that as quick as possible because we're losing money for that bug to be out there. Now people who wanted to see surfing videos in California can't see them because they're not in Minnesota. And now they're mad because whatever, Netflix or whoever, it isn't serving them the things that they want. And now they're going to have a bad experience. And now they're not going to want to come back to my video site or whatever. Like that's a problem. But if I can catch that really quickly in development, that's really cheap. Oh, yeah, you're right. I totally typoed that. I guess I was thinking about my grandmother who lives in Minnesota and I typed the wrong thing. Thanks. Okay, I checked that in. Boom, fixed, done. Couple seconds. As opposed to like, oh, now we got to get this thing out into production and we got to get special, permission from the vice president to push an emergency change and all. So expensive, takes so much more time. So we want to catch those things early. And another thing that we can do to lower our change failure rate is this idea of feature flagging. And I won't get too crazy into what feature flagging is, but feature flagging basically means that I can change some aspect of the software that's in production without pushing out a whole new release of software. I can literally go into like a database or however people implement their feature flags and say, turn this on or turn this off. But not only do I have the ability to say, turn this feature on or turn this feature off, but I have the ability to control how that feature is deployed. So I can say things like, only deploy this for people inside the company. People who are logged in inside the company can see this so that I can test this in production, but nobody else sees it. None of my customers see it. Or I can say, only turn it on for people who have agreed to be beta testers. Or I can say, only turn it on for 5% of people who come to the site. And over time, I can say, instead of 5%, make it 10%, make it 30%, make it 50%. I can turn on these knobs to be able to, test these features out and stuff like that in all kinds of different ways when I'm good at feature flags. And that really is going to lower my change failure rate because it allows me to do testing in a limited capacity so that I find out about problems before it's something that becomes like a really big deal. And so, one of the best things about them is like, if you deploy something that there's a failure and, on this new thing, you can just turn it off instantly. Boom, it's gone, it's done. And so that's really going to lower the impact that we have. And so the last thing that we're going to talk about is time to recover. So we just talked about feature flags, obviously allows us to recover very quickly. But it's this idea of like, how long does it take before we can fix problems, right? And so we have discovered there's a problem, now we need to fix it. And so lots of these things are architectural, right? Like, let's not deploy architectures that have single points of failure. Because if I have a single point of failure, then when I do have a failure, now it's all hands on deck, everybody's running around like crazy people trying to fix it or whatever. We don't want that kind of thing. We want our time to recover to be very quick, but also how do we know? How do we know that there's a problem, right? And so, for our practical things here, the first thing is monitoring, right? And so we have to be able to understand when there's a problem, and that this is a capability that we need to get good at, right? We talked about, time to recover, change failure rate, lead time for change deployment frequency. If we're good at these 4 things, remember, we're twice as likely to meet or exceed our organization's performance goals. And so one hilarious, I guess you can say it now, hilarious digital transformation thing, right, was the launch of healthcare.gov. I don't remember how many people remember this during the Obama administration, but there was going to be this big thing of like, we're not going to do healthcare by, just people filling out paperwork anymore. Now we're going to have healthcare.gov. You can get on healthcare.gov. You can sign up for healthcare, health insurance in the US. It's going to be this revolutionary thing. This is digital transformation, right? So, as the story goes, they were having a lot of trouble with healthcare.gov. It's crashing all the time. It wouldn't stay up or whatever. So they brought in this Google engineer, Mickey Dickerson. You can go look up some of these stories. They're hilarious, especially if you hear him give like the talk live. But he showed up and he was like, hey, how do you know when there's a problem on healthcare.gov? And they're like, well, what do you mean? He's like, well, what's telling you that that the site is down? And they said, oh, well, we have a television in this other room over here that's tuned to CNN. And whenever CNN says that there's a problem with healthcare.gov, we know that the site is down, right? That's probably not the best monitoring system in the world. Like we don't want to have CNN announcing to the world that our site is down. Like that's kind of lousy monitoring, and there's a huge delay there, right, between when you have the failure and when you find out about the failure. So monitoring is a huge thing. We need to be able to understand, when the site is up, when the site is down. We always want to find out about the site having problems before any of our customers call. We don't want them calling the customer support line complaining. That's a really lousy way of finding out about problems on the site. So we want to minimize our time to recover by getting good at monitoring. And the other thing would be application failover. So we talked earlier about we don't want to have single points of failure inside of our application. We want basically our application to recover instantly if we could possibly can do it. So, if I have 10 web servers and one of them dies, now I have 9 web servers. That's okay. The site's going to keep running on 9 web servers. If not, then, we should probably look at the number of web servers we're running or whatever. But like if I'm on something like AWS, I've achieved my digital transformation. I'm operating in this digital manner. AWS will replace that failed web server for me automatically if I put it in something called an auto scaling group, which doesn't really matter for the purposes of this. But like that means like I was running with 10, then I was running with 9 for a while, and now I'm running with 10 again, like 2 or 3 minutes later. That's pretty awesome, right? I've been able to recover, and that means I'm good at delivering software, right? And this is sort of the point. We want to be good at delivering software. And so, as my last example or whatever, since I saw that a bunch of people from Salesforce are going to be speaking at this conference, I used to be an architect in technical operations at Salesforce. I designed a lot of the way that site operates and stuff like that, and implemented it. But in the past week, they've just announced Hyperforce, which I know is a terrible name, like it's like Star Wars or something like that. But Hyperforce is Salesforce infrastructure running on public cloud. They can run this stuff on Amazon, on Google, on Azure, on all the big cloud providers, stuff like that. They're not running it in the data center anymore. And when I was working at Salesforce, it was all in the data center. And the data center, this is a pretty big digital transformation for Salesforce to be running stuff on public cloud. Because if I want to deploy in the data center, I got to order, I want some more stuff. I got to order the parts from the vendor. Then the server shows up. Someone has to unbox it. Then they have to go over and put it in the rack. And then they have to plug network cable into it. And then they have to give it power. And then the network folks have to be able to make sure that you can talk to it. And then the systems folks have to put an operating system on there. All these things have to happen over weeks and weeks and weeks in order to be able to get some more capability. If I'm running on public cloud, I make a call, 5 minutes later or whatever, my new server pops up and I'm done. I'm ready to go. And so even companies like Salesforce recognize the value in digital transformation, how important this is for them to be able to compete in the marketplace. And so even they're going through these digital transformations, and even Salesforce and big companies like that are, you know, embracing this idea of DevOps, of being able to run software well. And so, you know, the goal of digital transformation from my perspective is agility. And being good at delivering software gives you that agility. So get good at delivering software. And that's it.
Great, thank you. Wonderful talk. Some questions that I want to ask first, and then we can go to the audience if they have any. So the earlier 3 talks you heard today, I don't know if you were on for all 3, but 2 in healthcare and 1 in financial, and the talk to follow you in telecom. The one common theme in all those industries, do you know what that is?
The what?
One common theme across those industries. They're all highly regulated.
Regulation?
Highly regulated.
Yeah.
So question is, how do you apply the principles of DevOps where you do multiple releases every day, you learn from mistakes very quickly and make fixes very quickly? How do you apply that in a very regulated environment? So let me answer part of that question myself, and then I'll give it to you. In healthcare, as an example, there are functions that are not critical, that you don't need FDA approval for example. For example, the patient intake system that Luke was talking about in the morning, it's simply an interface where a voice assistant can talk to you to help you schedule with a doctor. It's not a matter of life or death. You could improve the performance of that and do multiple releases, fine. But you don't want to be doing that level of number of releases on, let's say, a robotic surgery system, right? It has to go through its approvals and so on. So just want to get your overall thoughts on how you tackle that problem with customers you work with across regulated industries.
Yeah, it's a great question. It's something we've talked about for a long time in the DevOps movement. So there's a couple of things. One is, you know, to your point, like there's different risk tolerances for different even different components of our company. And so, you know, famously Etsy, everyone has heard of them or whatever. All their financial stuff used to be like, John Oswald used to, I think, call it a walled garden, but like segmented off into a walled garden because there was specific regulations that were around that financial stuff. And so they had, you know, the rest of the company was sort of over here. And then that heavily regulated area was like sort of segmented off. But I think the other thing that's important really is that the goal of regulation, the goal of like all these like SOX and PCI and all these other things or whatever, is not to tell you what to do or how to do it. It's to tell you the set of criteria that you need to satisfy in order to be in compliance. Right. And generally, the auditors and stuff like that don't care how you achieve that as long as you achieve that. And so, you know, I've gone through tons of audits over my career and stuff like that. And the funny thing is that what used to happen was that the auditor would show up and say like, hey, can you, you know, pull this machine or pull that machine and show me, prove to me that what you say that you're actually doing is what you're actually doing, right? You're telling me that you configure this way and you have that way. Pull this machine out and show me. And that's how we used to do it, like back in, you know, the early part of this century or whatever. But then, you know, the rise of the DevOps movement came and stuff like that. And we started using things like configuration management tools and stuff like that. And I always said a configuration management tool is a compliance engine, because all the configuration management tool does is it wakes up every, whatever it is, let's say every hour, and says, is the policy that's defined for what this thing should look like, is it in compliance with that? And if it's not, I'm going to fix it. And that's what the configuration management tools used to do. They just used to bring things into compliance. So now when the auditors show up and they say, hey, show me this machine or that machine, I can say, I can show you this for all 10,000 machines that we own. Like, here's the logs. Here's the proof that every time something has fallen out of compliance, it's been fixed. this is what fixed it. This is what time it fixed it. These were the code that was checked in that makes that thing be fixed. And they're like, awesome, you know, and they just check it off. And so, you know, if you really want to dig into this, there was a paper I wrote with IT Revolution. It's called something like DevOps in the Age of Audit or something like that. And we talked specifically about this idea of separation of duties, because that's in the PCI, you know, compliance thing or whatever. Yeah. And everyone says that the way that you fix separation of duties is to say, like, developers can't push stuff to production. That's not what separation of duties says. Yeah. Separation of duties says that there should be checks to make sure that a single person can't control this code or whatever going from their desktop all the way into production without anybody having any kind of say or review or stuff like that. So what we found in the DevOps movement is that auditors are fine with us coming up with new and creative ways to get stuff done, as long as it satisfies what they're looking for. They don't want to tell us how to do our jobs. They want to make sure that we are proving that we are doing the things that we said, and we're satisfying all of these different regulations and stuff. And so, yeah, I think it's great. I think it's also like a really important thing for people in these regulated industries to be able to look at these problems in a new light and say, like, how can I satisfy the requirement in a way that allows my business to both move fast and to be able to prove that we're actually doing the things that we're supposed to be doing.
Good. Thank you. And one other question. So the emergence of serverless computing and Kubernetes and those kind of computing platforms, does that hinder things for DevOps, or does it make it simpler?
Really neither. Like, you know, one of the other great things about the State of DevOps report is that one of the things that we learned was that architecture matters and technology doesn't. Okay. So like serverless, Kubernetes, all those things, those are technologies, right? I mean, they feed into architectures. There's no question about that. But really, like, you know, to be good at delivering software, whether my container goes out on serverless or whether my container goes out on Kubernetes, there's still all kinds of other things about that. Is that container coming from a trusted source that my security team has blessed and says has no vulnerabilities? Or does the base of that container come from just some random thing that one of my developers pulled down from some website deep in Russia off the internet? You know, like, there's that. Then, you know, there's like, how much testing am I doing? Like, what kind of testing is it? Is it unit tests? Is it integration test? There's so many different things that we have to take a look at in the path to production, that like ultimately how that stuff is deployed definitely matters. It definitely makes sense. But our ability to deliver software well is not going to be based on just, you know, whether I chose, you know, Kubernetes or I chose some other kind of competitor to Kubernetes.
Got it. So what you're saying is the architecture matters, the paradigm matters, technology is secondary. Yeah. I mean, it's important, but yeah, in the bigger scheme of things.
You're not going to beat your competitor because you chose GitLab versus GitHub.
Yeah.
That's not the differentiator. If that's your differentiator, then you already lost, because anybody can turn around with their credit card and buy what your competitor has, and now you've lost your strategic differentiation. Like, that's why the stuff from the lean startup and all that stuff is so important, is because I want the thing that makes me different than my competition, the intellectual property that my company develops, the special sauce that we have, the ideas that we have are better ideas, the data that we collect is better data, whatever. I don't want it to be something that my competitor can turn around and buy with a credit card, because that's not going to be the difference.
Good.
DevOps efficiency helps IT succeed. In the context of healthcare, do you see IT to be a part of hospital management or an independent entity? Great question. So I think the funny, and I've given entire talks on this specific thing, but like, I think the thing that people get hung up on with the word DevOps is it says dev and it says ops. So therefore, DevOps is about dev and ops, but like really, DevOps is a software development paradigm that applies to the entire business. And so I'm not a big fan of outsourcing or anything like that, because I think in order to succeed in business, we have to look at the entire system. And so for people who are super interested in this, you can go look up, it's called The Three Ways by Gene Kim, or read The Phoenix Project, which is like, you know, certainly his most famous book. But it's this idea of systems thinking. We can't look at a silo. We can't look at an independent part of an organization and decide whether the company is going to succeed or fail based on that independent part of the organization. We need to look at how that part of the organization fits into the larger organization. How does it feed into our business objectives? How does it feed into the goal that the business has? And so, you know, I won't go too far into this, but like, you know, I've worked with the marketing department on in a DevOps idea, like, hey, this is really inefficient. We're releasing software. Our customers don't know about it for 3 weeks because after we release the software, the marketing department has to get all their stories together. They have to figure out where they're going to put this. They're all these kinds, that stinks. Like we have software that we paid for that's been in production for 3 weeks that we can't make money on because nobody knows about it. And so what we wound up doing is bringing the marketing department in much earlier so that the day that the software was out, the tweets went out, the white papers went out, the emails went out, all that stuff went out so that as soon as that software was released, we could start making money on it. And so, you know, here the question is about like, how does IT fit? You know, is it an independent entity? Is it part of hospital management? IT should be viewed in the context of the hospital system. What are the goals of the hospital? What is the hospital trying to achieve? How can IT help achieve those goals? Because it's an integral part of the entire system, and every part of the system has an important part to play, whether it's legal, whether it's marketing, whether it's IT, whether it's development, whatever. All those different things have important parts to play, and only by like taking this systems thinking view are we able to really optimize the flow of work through the system. And you know, when we optimize the flow of work through the system, we're going to deploy faster. We're going to have less failures when we deploy. When we do have failures, we're going to understand those things better. You know, all the things we just talked about. So it's a great question. And DevOps is not just Dev and Ops anymore. DevOps is how does my organization function? And how can I optimize the, you know, to get the best results that I can possibly get for my customers, where my customers could be patients, my customers could be all kinds of different, you know, people.
Thank you, Dev. Thank you very much.
Sure.
Great answer and great talk. Thanks.